Hey guys, Mr. B here again, bring you another math video. Things have not been working out for me today trying to get this done, but alright, let's give this a shot. So, trigonometric derivatives and the chain rule part 1. So the first thing I should mention before I forget, I have a worksheet attached with this lesson, and it's just in the comments. I'll put the link, and if I can get a card, I'll put a card there as well. So if you want to download the worksheet and kind of just do it on your own and check it with my solutions, and or you could do it, as I go through it and then try a couple on your own. You can, but since it's like 12 or 13 problems, I think I got it broke up into a couple different pieces. So this is the first video. I'm gonna do the first 5. Alright, so this video is all about using the chain rule and your trigonometric functions. So first of all, the chain rule, for those of you who don't remember, is y is equal to f prime of u times u prime. You will use it when you have a composite function. So that's a fancy way of saying you have a function in another function. So what that means for trigonometric derivatives is there's something inside of sine, cos, tan, cosecant, secant, and cotan that's not x. So it could be something, fairly complicated, like a root or a cube root. Could be another trig function. Could be a just a quadratic or a linear function. So before we even attempt any of those things, we have to look at our known trigonometric derivatives. So these are our known trigonometric derivatives, and these are the ones that you need to know if you're doing this stuff in a calculus class or in my class. So these are the versions that I show my students, and they're already in chain rule format. So this is the way I prefer to know them. This is what I think in my head when I'm doing these questions, and I always say when I'm teaching any course, I always say this is what is going on in my head. So there's questions when you're doing math that you have to ask yourself, and when you're doing this stuff, the question you'll ask yourself most often is, what's the derivative of sine? It's this. What's the derivative of secant? It's this. So you need to just know that off the top of your head, and that's best if if the course that you're doing doesn't have a formula sheet with it, which I've never done a calculus course with any type of, known derivatives given. Be nice if they would do that, but they don't. Alright, and I don't either because I would get yelled at. Alright, so let's give this a shot. So these are our known derivatives, so write these down, or you can print the sheet that I have with these attached on it. So let's try the first one. So the first one is cos. So the derivative of cos is negative sine. So I'll need a pen for this, won't I? Let's see if I can't. Let's choose red. And let's make it a little bit skinny. Alright, so. Oops. Here we go. So derivative of cos. So it's y prime. And it's negative sine. So this is how I like to do it. I just simply think, what's the derivative of cos? Well, the derivative of cos is negative sine. And I don't really care about what's on the inside. I just go ahead and rewrite that. So what's on the inside is 7x squared. So I just simply rewrite it. And then I need to remember that because there's not an x here, there's something other than x, I need to take the derivative of that something on the inside. So my students like to write it out, that something prime. So the reason why they like to do this is because sometimes that something is extremely complicated and they want to take it step by step. So now the derivative of that something, we'll use the power rule. It's just a polynomial. It's a quadratic, a monomial. So 7 times 2 is 14 x. So we end up with negative 14 x. And then I'll rewrite the sign. So I took the negative from the sign and just tacked it in front there. Sine 7x squared. And there it is. That's all she wrote. So that's our first trigonometric derivative with chain rule. Alright, let's give the next one a shot. So it's something more complicated. So it's always a little more complicated when you get cosecant or secant because their derivatives, if you noticed, have two pieces. So they have two trigonometric functions that you get as a result. Some people find that confusing, but don't be confused. It's nothing different. So the derivative of cosecant is just negative cosecant u cotan u. So that's our first step. So we don't really think too much about it, just write it. Negative cosecant 4x plus 3 times, and then the other part is cotan 4x plus 3. So you know, there's in most of your calculus courses, you should probably start out doing this by doing the proofs of these things, and then you get them. And at the end of the day, you need to know how to use them. So don't stress too much about where they come from. I suggest knowing the proofs of sine and cosine, but you know, the other stuff is just they're just the result of those. So that's our first piece. And then we just, because we have that derivative on the inside, it's the derivative of 4x plus 3. And you're probably thinking, I don't need to write that, which is perfectly fine. If I was doing this for myself, I wouldn't write that, but I'm just taking it step by step slow for you guys. So derivative of 4x plus 3, bam, it's 4. So I'll tack that negative 4 right out in front there. And then I'll just rewrite cosecant 4x plus 3. And then cotan 4x plus 3. And there it is. So that's a, you know, a fairly difficult trigonometric chain rule. So let's try another one. Let's step it up a notch even still. So here again I got a secant, so that's a complicated just in itself because it has two pieces, but I also have a square root inside, which ups the level even more. And what's different about this one is that there's something inside that square root that's not just x, it's 3x. So this is actually a chain rule within a chain rule. So let's have a look at it. So first of all, what's the derivative of secant? Well, the derivative of secant is secant tan, I do think. Secant tan, yep. So secant square root 3x, and then it's tan square root 3x times the derivative of what's on the inside. Just like that. Alright, so the thing you got to remember is that a root can be rewritten as this. So this is what I'm visualizing in my head. I often don't write it, but that's what I visualize. And if you're not sure about the derivative of radicals like square roots or cube roots, I think I have a video on that, so you can go back and check that out. Maybe I'll put a card here too. We'll see. I'm getting fancy. Alright, so the thing of what makes it a chain rule within a chain rule is I've already done the chain rule once, but now to do this u prime, I have to use a chain rule again. So that's a chain rule within a chain rule. So let's rewrite. And then rewrite again, tan square root 3x. So the derivative of root 3x, well, I'm worried about the derivative of that, just that root first. So 1 over 2. So I take that exponent down in front. And then the 3x stays. And then I subtract 1 from it, so this guy goes in front, and then I subtract 1. So subtract 1 from a half, it's negative 1 over 2. And then since there's something inside, I had to take the derivative of that, and just for the sake of completeness, I'm going to write that derivative. So that's what my students do. Individual steps, they're just breaking it down step by step, and there's almost like one piece done in each step. So now the derivative, of course you could have did that just then because the derivative of 3x is 3, but just for the sake of learning for the first time. So derivative of 3x is 3, and then we're going to combine it with that half. So secant square root 3x tan square root 3x, and then 1 half x 3x to the negative half, and times 3. So I'll rewrite this. I'll put my 3 over 2 in front, and I'll even put that 3x all to the negative half out front as well, and then just my secant root 3x and my tan root 3x. I don't know why I got that bracket there, but I'm not going to erase it, but it shouldn't be there. So one thing that some of your teachers or your professors might want you to do is get rid of this negative exponent. So I don't personally, for me, it doesn't really matter. This still means the same thing. But if they do want you to get rid of that, this is what it would look like. So negative exponent takes things to the denominator. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. And there, I wrote that bracket again. Dang it. All over. So I already got a 2 here. So just be square root. So when I take it down to the denominator, it becomes a positive half, and then it becomes a square root 3x. So that's one way you could possibly see it. But personally, I prefer this way. I tell my students you can use whatever way you want, but chances are for my students this will be a multiple choice question with, you know, CPT would be like 6 possible answers, and they just got to match it up to the best one that looks most like theirs. Alright, let's do 2 more. So this one is a little bit different. So the examples so far that we've done, the trigonometric function has been the outside function. In examples like this one, the trigonometric function's actually the inside function, and that exponent 3 is actually the outside. So this is how I like to rewrite these questions, and it makes it, you know, a lot more obvious what you got to do. So the 3, the exponent 3 is the outside function, and the trig is actually the inside function. So I ask myself the question, what is a derivative of something to the 3? Well, it's 3, the exponent comes down in front and smacks right in front, and then that's something, and then I subtract 1 off that 3, so this is just the power rule, and I get squared. And then, since I have an inside function, is what's the derivative of sine 5x plus 1? Just like that. So the derivative of sine x plus 1, so I'll rewrite this first of all. 3, trying to be a bit neater this time. And I'm going to bring that exponent back to here, so squared, just to make it look a little bit neater and like it was given to me originally. Plus 1, and that's not an 11. It should be another bracket. And then bracket times the derivative of sine is cos, and then the 5x plus 1 goes back inside there, times the derivative of what's inside the sine, which is 5x plus 1. So this is still a chain rule within a chain rule, so there's a little bit of work to it. And then the last step is to take the derivative of that guy right there, and I know it, that is 5, so I'll multiply just to save myself a step. That 3 times 5 is 15, so that's equal to 5. And then it's just sine squared 5x plus 1, and then cos 5x plus 1. And there it is. So if you ever encounter a sine or a cos or any trigonometric identity, if I can say that word correctly, with a power, it's best to do it this way. Alright, let's try another one like this. So we got a cosecant. So first step I'll do is rewrite. So cosecant root 6x all to the 4. So I'll do the derivative of this guy. So 4 comes down in front, and the derivative of sorry, got ahead of myself, don't want to do that. 4, then I put my cosecant back inside here, cosecant square root 6x, and then I drop a power 3. Then I have to take the derivative of that cosecant root 6x. Alright, so 4, and then I'll write my cosecant now with that 3 on the inside, just like I did in the last example. And the derivative of cosecant is negative cosecant cotan, so negative cosecant 6x cotan 6x times the derivative of square root 6x. There's a lot to this one. Alright, so this looks like there's going to be at least 2 more steps. So now we need to get the derivative of root 6x. So I'll kind of skip a step in this one just to save myself a little bit of work. So first of all, I'm going to take that negative and put it to the outside here with that 4. So that 4 and that negative is going to go together. Also notice that this cosecant and this cosecant can be combined. So we can add the exponent. This has an exponent of 1 that has a 3, so it becomes cosecant to the 4, just like that. And then root 6x. You can only do that with trig functions. You have to have exactly the same. It's the exact same trig function, and they have the exact same thing inside. And then cotan stays like this. And a derivative of square root 6x. We already did one like this, guys, so I'm going to skip through it. So 1/2 6x to the negative half. And then I have to take the derivative of 6x, which is just 6. So 6 times 1/2 is 3 times negative 4, negative 12. Cosecant to the 4, 6x. Cotan square root 6x, and then I'll just leave that 6x to the negative 1/2 there by itself. And if you want to take it to the bottom, it will look like this: negative 12 cosecant to the 4 square root 6x, getting a little sloppy, cotan square root 6x, and then that becomes square root 6x. Alright guys, I hope you enjoyed this video and you learned something. And again, worksheet you can download, and please share it if you have friends doing calculus. Thank you very much, and I will see you guys in class. Thanks for watching.